Hi 6th graders, it's Miss Wallace again. We are now on our about 4th week of taking notes by video, and this week we're going to actually talk about a three-dimensional shape. So this week we're going to talk about volume of rectangular prisms. And so first we're going to talk about what this shape is, what these words mean. And you've probably talked about a rectangular prism before. It's actually just a fancy word for a box. So for example, just think of it as a box. You may have been taught to draw them like this, kind of draw a rectangle, and then maybe a rectangle above it, and then connect the corners. And so we're thinking about a box shape. And so that's the three-dimensional shape that we're going to talk about. So we call this 3 dimensions. Or you may be more familiar with 3D, which just means that are able to measure a width, a length, and a height of this shape. And so if you think about the ways that we might measure this, number one, we might measure the width. So we might say that this is W, the width across the box. The length is the second dimension. And so the length might be this measurement that kind of goes backwards here. I'm going to write a capital L because, again, a lowercase l kind of looks like a 1. So the length, and then the height, which is just how far the box goes from the bottom to the top. And so we're going to call this measurement h, the height. So that's why we call this a 3D figure. It's got 3 dimensions: length, width, and height. Now we're going to talk about what does it mean to find the volume of something. So volume is defined in this way. Volume is the measure of the amount of space inside a 3D figure. And so we're talking about how much is going on the inside of this box. So if you think about maybe this is a pool and you're filling it up with water, how much water will go inside? Maybe it's a Christmas present and you're thinking about how many presents am I going to be able to put inside this box? Maybe you're mailing something glass and you're filling it up with those styrofoam packing peanuts. Do y'all know what I'm talking about? The little squishy things. How much am I going to have to fill up this box? And so we're talking about the inside of the box when we're thinking about volume. So there is a formula that we're going to use to find our volume. And so we're going to use V, a capital V, to represent volume. And it's actually quite simple. Volume is equal to length. Again, I'm going to use a capital L to represent the length, times the width, which is, again, this measurement, times the height. And so it's just these 3 measurements. We multiply them all together. Remember, when we write letters right next to each other, that means multiplication. And so we're just going to be multiplying 3 numbers together. So let's look at some examples. So let's say example number 1. Let's say that you are given a box, and let me draw one here. So let's say it looks like this. And we'll connect that. And let's say you are given that this measurement is 4 inches. 4 inches here, and let's say you're given this measurement is 8 inches, this measurement here, and let's say you're given this measurement here is 3 inches. And we're asked to find the volume. Again, that's how much will this box hold inside of it. And so we're going to copy down our formula. Volume is equal to length times width times height. And we're going to define each of these. So what is the length here? Well, you could really call any three of these numbers the length. I'm going to call, let's say, the 8, this measurement here. Let's call that the length. So I'm going to label that. The length is equal to 8 inches. Which one's the width? You could really call either of these the width, because actually you could turn a box around and you could define any of them as width. I'm going to call the 4 the width. And 3 most obviously looks like the height, so I'm going to call it h. So I'm going to plug in my numbers. So volume is equal to my length, which is 8. Plug that in for L, times the width, which is 4 in our case, and then times the height, which is 3. So I'm just taking those three numbers, multiplying them together. Grab a calculator, and we're going to multiply these three numbers together. So 8 times 4 times 3. Multiply them together, hit equals, you get 96. And that is our answer. Now it's 96 units. We've got to look back and it's inches, so we're going to say 96 inches. Now, because we're multiplying 3 of these numbers together, remember we used to say that area was squared, so we're going to introduce a new concept here. Volume is actually going to be cubed. You're going to have a 3 floating up in the air above your units because we're multiplying 3 together. That actually indicates that we could actually take teeny tiny little cubes. If you think about what a teeny tiny little cube would look like, how many of these little cubes could you fill up this box with? And so that's where we get that cube. Sometimes you'll actually see it written like this, 96 cubic inches. You might see that 3, you might see it as CU, which stands for cubic. So we could read this as 96 inches cubed or 96 cubic inches. Either way, that is going to be your final answer. All right, let's look at another example. Example number 2. And let's say we've got a real skinny long box here. Oh, that's really bad drawing, y'all. That's really bad drawing. Oh, that's so bad. Get rid of that. I didn't follow my own advice. All right, let's draw that again. So let's say it's really skinny. And let's draw our second rectangle back here. That's what I didn't do the first time. Here we go. All right, and let's say we are given the measurement here is 6 feet. Let's say we are given the measurement here is 12 feet, and let's say we're given the measurement here is 1 foot. And so again, we're asked to find volume. How much will this take to fill it up? Write down your formula, length times width times height, and again, it's just as simple as multiplying these three numbers together. So we might call 6 the length, so we put 6 in there. We might call 12 the width times 12, and we might call 1 the height, so times 1. Multiply those numbers together, 6 times 12 times 1, and we get 72 feet. Remember, our unit was feet cubed, or we might say 72 cubic feet. Either one you might find is your answer. So that is how you find volume. We're going to look at one more example of what a problem might look like. Sometimes you will actually, we mentioned cubes and what it means to be cubic. So example number 3, I'm going to draw this very carefully. You might see something that looks like this. So you might actually see it defined in terms of actual cubes. So your image might look something like this. And so you might see it where it actually looks like little tiny blocks or little tiny cubes have been put together to actually form some units along the side. Now you will be told that, hey, you know, this looks like 2 cubes, or let's say maybe 2 inches. This might be 1, 2, 3, 4, 5 inches, that each block is worth like an inch. If you think about maybe blocks that you play with when you're a little tiny kid, or those little tiny centimeter cubes that we use sometimes in class. So there's 2 across the front, there's 5 along the side, and then if you can tell, this is 1 block high. It only takes 1 block to make up the height of this. So sometimes you'll see the individual blocks defined. That doesn't really make a difference as far as what we're doing here, because you are still going to be given a length, a width, and a height. And so since volume is length times width times height, we would plug in, maybe let's say 5 is our length. Again, it doesn't matter which one of these numbers you call the length. 5 times, let's say 2 is our width, so we would plug in 2, and then times 1, which would be defined as our height. And so when we multiply those numbers together, you can probably even do that one in your head. 5 times 2 is 10, and times 1 again is 10 again. And so 10 inches cubed, or 10 cubic inches, it might be written as. And that is how you find the volume of a rectangular prism.